we are WARR Rocketry, a student team based at Technical University of Munich, Germany. We are at SAC with the project called WASP, an experimental platform for the development and testing of subsystems that fall outside the focus of our sister project Nixus, a cryogenic biliquid rocket pushing the frontiers of student-built propulsion technology. Our project wouldn't have gotten this far without our two project leads, Ludwig Zappa, who led us from the beginning of the project, and Anibal Guerrero Hernandez, who is in charge of developing our in-house simulation tool WASPR. We are a student team working under the student association WARR, which in German is short for Scientific Workgroup for Rocketry and Spaceflight. The student association shields a multitude of projects, from experiments sent to the ISS, through student-operated satellites, autonomous rovers, space elevator projects, and of course, student-built rockets. Project WASP entered the SAC with one goal in mind: to create a staged rocket using a self-developed staging system. The sustainer bow tail, an aluminium 3D printed part, stands at the center of the system. It is the load-bearing part, transferring thrust loads, doubling as an aerodynamic cover, and in addition to all this serves as the staging interface to the sustainer. This, however, is not the only metal 3D printed part in our rocket. Hiding under the booster bow tail is the booster motor mount, a titanium 3D printed part transferring 1,800 pounds of force from the booster engine onto the rest of the rocket. Most of the remaining structure comprises of wound carbon fiber skins, which on the sustainer, being slightly thicker than 1/16 of an inch, transfer all loads throughout the flight. To safely return our rocket back to the ground, we have two recovery systems, one for each stage. The sustainer has a nose cone system, tested multiple times, utilizing CO2 pressurization to release. The booster has a sideways system, employing rope cutters and its own packing pressure to release the parachutes. Both systems were employed in our test launch in Germany. It was a big test not only of our system, but also of the team. In the end, we pulled through and managed to get a rocket into the air successfully, an endeavor we hope to repeat here at Spaceport. Included in the said launch was our own computer, a system similar to the one we are flying here. It can send live telemetry and video, which we will hopefully see during our flight. We expect our flight to take us all the way to Mach 1.4, where aerodynamic heating must be considered. That is why the tip of the rocket is made out of aluminum and is as sharp as possible. After we reach our maximum velocity is when our payload starts to shine, literally. Dynalabs aims to study biofluorescent algae, Pyrocystis noctiluca, using optical measurement techniques such as cameras and photon sensors under microgravity, and to determine the quality of said microgravity by comparing the results to existing research that was performed in the drop tower test. The team is excited and ready to get our rocket into the air and give this wonderful journey of ours a successful ending. Go WASP!
3, 2, 1, WASP! Let's go!